see my voice. So I'm going to start.
Perfect.
Okay, so sorry about that slight delay, everybody. We're having a slight clunky technical issue. So you're seeing Rhodri Leng today throwing his voice. I am speaking to Sam speaking. So I'll just quickly do a round of introductions. So Rhodri, if you could just look pretty for me, that would be great. So thank you everybody for joining. Welcome all our newcomers and all our regulars. We've got a fabulous set of speakers coming up May to July. So be sure to check out our Twitter page at RIOT Science Club and our website www.riotscience.co.uk. You can check out all of our previous content via the links I've put in the Q&A. So our YouTube channel with talks from Alexandra Albakian, the creator of Sci-Hub, Stuart Ritchie, Talia Arconi, you name it, we've most likely got them to speak at one point or another. But today we have Rhodri Leng. Rhodri, and you can't see me, but I am holding up a book that he co-authored with his father called The Matter of Facts, Skepticism, Persuasion and Evidence in Science, and I'll put a link to it in the chat. Rhodri is a quantitative sociologist of science. His research concerns developing understanding of how the structure of citation networks affects the spread of information across the scientific literature, how the spread of information affects the development of scientific opinion, and involves integrating this understanding into theories of scientific development. And an important element of his work involves developing methods to detect citation bias and other citation distortions in the literature. And Rhodri will go through this today in what will be, I'm sure, a very interesting talk. So I'm handing the keys over to you, Rhodri, and thanks for taking time to give a talk today.
Excellent. Well, thanks for the introduction. Can you see the slides and hear me okay?
Yes, everything's fine.
Okay, so it's a huge honor to speak here today. As Sam mentioned, I recently co-authored a book, The Matter of Facts, which is this is the front cover of it. Which is a series of short essays about science. It's not a book just about problems in science, but we did intend it to help outline and contextualize an array of problems that are affecting the reliability of published evidence at the moment. In this talk, though, I'll be focusing on one topic that reoccurs throughout the book, and about how evidence is cited in the scientific literature, and some of the biases that shape how evidence spreads and is interpreted. The first half of the talk is going to focus on the dynamics of citation, while the second half will focus specifically on citation bias and distortion. Now, there's already been some wonderful talks at RIOT on similar topics. Chris Jackson gave a talk recently on publication of citation metrics. Dorothy Bishop had a great talk on publication of citation biases. And Marcus Manufo's talk on research ecosystems and incentive structures is great as well. So I've tried not to cover the same content here and recommend that if you're interested in anything I say, that you also kind of follow up with these talks. I'll be drawing from a small number of empirical studies to illustrate a few points, and I'll include a list of relevant literature at the end of the slides, and I think we're uploading the slides to some kind of sharing platform after this. So before moving on to the modestly depressing topic of problems of citation, I'll talk about citation dynamics. And to do this, I'm going to survey the history of a peptide hormone, oxytocin, with citation network analysis. Why oxytocin? Well, we wrote a little history in the book that people seem to enjoy. So this is a bit of a follow-up on that. But I'm using this here primarily just to give us a sense of the complexity of citation networks and to introduce you to some of the peculiar regularities of citations. And these regularities we need to know about before we can make kind of sensible use of citation metrics, if there is such a thing. And now I'll be building up to problems gradually, easing you in. So if you're here for bias, I will get to it. So what is a citation network? Well, it is a simple method really for representing the scientific literature on any given topic of interest as an interconnected network of papers with connections going from a citing document to the cited. And here's just a little hypothetical, very simple network I've built for you here. The nodes represent papers, and the edges between nodes, which are these arrows, represent citation links, with going from the citing to the cited document. And what I'll do is I'll talk you through how you quickly make one. I won't be going into too much detail here, but I think it's good to kind of pin this to this empirical example of oxytocin. So to make a network, we need some data on publications and their references. And for the following, I've used a very simple query on Web of Science. And I've just searched for the terms oxytocin and two terms commonly used for synthetic oxytocin in the titles of articles and reviews. And so this is typically primary research articles and reviews, though Web of Science classifications are not always brilliant. And I've restricted the results to everything published as of 2020. And this retrieved about 11,000 articles and reviews published between 1928 and 1920. And figure 1 here, you see the kind of trend in the literature there. So this is publications per year. Now, of course, there was research on what we would now understand to be oxytocin before this, but oxytocin was only given its name in 1928 by the chemist Oliver Kahn, so it could only really start appearing in the titles after this as kind of necessity. I've restricted the results here to look only in the titles because I just want to give you a very kind of a sketch of a long history here. So not many know this, but if you do a topic search, which is searching for terms in the titles, abstracts, and associated keywords, you'll bias a search if you're looking over a long period of time because abstracts and keywords tend not to be indexed for literature until 1991. And so you'll see this artificial rise in publication trends in 1991 if you were just to use this query via a topic search. And topic searches also kind of pull in a lot more literature in which oxytocin will only be peripheral to the research. Having oxytocin in the title at least gives us a reasonably good indication that oxytocin is one of the main kind of targets of interest of that paper. And so my query obviously doesn't capture everything that's been published on oxytocin, but what I'm going to use it for in the next few slides, it's going to be fine. And so it's kind of outline of a history, and we've got a paper that's coming out about this, which is a follow-up on this chapter in the book. And you can see it grew until around 1992, and then it suffered this decline in output, and it really took off in an incredible way from 2005. This is quite some research attention for a peptide. But I'll get onto these trends later because I think they're interesting, and I think they've got quite a lot to tell us about how publication and citation dynamics work. Now, Web of Science usefully tells us how many times this literature has been collectively cited. About 370,000 times by 100,000 papers to date. Now, this includes only the citations from papers indexed in the Web of Science, and so it will undercount the total citing literature. And as there has been a sharp rise in publication in the last few years, these newer papers are very likely to accumulate more citations over the next few years. Now, via Web of Science, I downloaded all the associated data for these publications, including their full bibliographies, which we're going to need for the network analysis. And this is a nice feature of Web of Science. So we can see what each of these papers reference, even if the papers that they reference aren't themselves indexed. So in total, there are about 450,000 references in these 11,000 odd papers. So the average reference list size of my little set of oxytocin papers is about 45. Now, a total of about 163,000 of these references from these oxytocin papers are directed at other oxytocin papers in this set that I've retrieved. So this is oxytocin papers citing other oxytocin papers, and by oxytocin papers, I mean papers with oxytocin in the title. And so this means that we know that about 45% of the total citations to this literature come from other papers in my query. The other 90,000 odd papers direct the remainder. And this means that oxytocin papers cite an average of about 16 other oxytocin papers, while a paper in the broader citing literature cites an average of just 2. So despite the simplicity of this query, we've managed to capture quite a densely interconnected literature here. These numbers only give us a sense of scale of this kind of vast network of interactions between these papers and their broader citing literature. And these interactions, if you think about them, each reference might modify, might reinterpret, praise, might amplify, might support a previous work. And so these are very complex webs of interactions between papers. And so for a deeper understanding of this, obviously, we need to read the papers and understand how they are actually being used in later papers. But for now, I'll stick with this quantitative description, as limited as this undoubtedly is. How then is this literature structured by the citation links? Now, I've created these little figures for you, and each node is a paper here, so you can't really see them, they're bad dots. So each node is a paper retrieved from my query, and the lines between nodes reflect direct citations from one paper to another. The position of nodes is determined solely on their connections to other nodes, and this helps us to visualize clusters of nodes that are densely interconnected. The algorithm that I used to visualize this network pulls groups of papers together if they're densely interconnected. That's all you really need to know to understand that, I think. So I've then partitioned the network into clusters via modularity maximization via the Leiden algorithm. And you don't need to understand much about this, apart from that it groups papers into these densely interconnected clusters quantitatively, and that these clusters are only sparsely connected to other clusters in this network. The nodes are colored by the cluster that they're members of, and we've classified each of these 10 clusters shown here into topics by reading a sample of the titles, the abstracts, and the full texts of papers. Now, almost all of the oxytocins captured by my query exist in a large connected network, and 97% of the papers from my query exist in such a structure. The figure I'm showing you here is slightly smaller than the total network, just for ease of my explanation. I've trimmed off some of the papers that are connected to less than 3 other papers, and I've got rid of 2 small clusters that I'm not going to be talking about here. So what you see then in figure A is how this literature clusters together when we consider all the oxytocin papers and the reference links between these as of 2020. So we could cut this up into time, but we're not going to do that. So what are these clusters? So I'll give you a very kind of snapshot overview of the history of oxytocin via this. It's an imperfect history, but we'll see how far we go with it. So for those who don't know, oxytocin is a peptide. It is produced by neurons in the brain, and it's released from nerve endings in the pituitary gland. After it is released, it circulates in the blood to act on various tissues, but it also acts in the brain. Each cluster here is pursuing different lines of research on what oxytocin is and what it does. So the black cluster down here, these are papers by chemists. In 1955, Vincent Duvigneau won the Nobel Prize for Chemistry for establishing the chemical structure of oxytocin and for working out how to synthesize it. Chemists really extended this work by developing a range of agonists and antagonists of oxytocin, and that's what that cluster is doing. And this ability to synthesize oxytocin led to its use in maternity wards to facilitate childbirth. And this is the purple cluster up here, and this is mostly written by obstetricians and include many clinical trials. Now, oxytocin is also essential for milk letdown in lactation, and the pink cluster right here in the bottom are papers mainly about milk yield in domestic animals from agricultural research institutes. Now, oxytocin acts on cells at oxytocin receptors, and the responsiveness of tissues to oxytocin depends on the properties of these receptors in those tissues and on their abundance. And this is the green cluster here, and this is focusing on those questions. And typically, these are papers written by endocrinologists or cell biologists. In the orange cluster over here, we see papers about oxytocin in sheep and cattle, and these are species. In these species, oxytocin is produced in large amounts in the ovaries, and this cluster is working out exactly what this is about. The ovarian cycles in females is controlled in different ways in different species, and so in sheep and cattle, the ovarian oxytocin is a kind of main regulator of this cycle, and so this is what's interesting them in that particular cluster. And again, these are papers that are typically written by physiologists or endocrinologists working at agricultural research centres. What else do we have? Now we're getting to the bigger clusters. In dark blue down here, these are papers that focus on the secretion of oxytocin from the pituitary and how this is regulated. What stimuli are important and how do those stimuli reach the oxytocin cells? These are mainly neuroscience papers and neurophysiologists. In the yellow cluster, beside it, are papers that are concerned with the behavioral effects of oxytocin in animals. Oxytocin affects stress, anxiety, maternal behavior, sexual behavior, and bonding. And so this is what is interesting, that cluster. Down here in green, beside it, is a small little cluster that's really concerned with the analgesic effects of oxytocin. And up here, the light blue cluster is concerned with oxytocin's effects on appetite and metabolism. And mostly these are written by behavioral neuroscientists. Finally, we come to the red cluster, which is the biggest cluster here. And it's kind of stuck on the end here. And these are papers on the psychological effects of oxytocin in humans, and many of these involve giving quite a large amount of oxytocin intranasally, so spraying it into the nose of participants. And these tend to be written by psychologists, psychiatrists, and neurologists. To the right here, I've plotted the number of publications published in 5-year intervals in each cluster, and we see some have risen and declined, some are currently declining, while others are steeply growing. Everything, it seems, has its time and a place, and this includes what questions are interesting, what methods are sensible to apply. And as you'll see here, the chemists kind of have had their day here. The neuroscientists are beginning to decline, whereas the psychologists are really on the rise here. Does this mean that chemists and physiologists have given up working on oxytocin? No, it doesn't, but it does reflect that oxytocin is no longer really the primary focus of many of their papers. It's not as interesting perhaps as it once was. Between the 1950s and 70s, if you were working on oxytocin, you were probably an obstetrician or a chemist. Between the 1980s and 2000s, you were probably a physiologist. And today, if you're working on oxytocin, you're probably a psychologist or a psychiatrist. Now, the most kind of consistent literature, it's always present, is the obstetrics literature, which is shown here by the purple line. So oxytocin has been, for at least 70 years, an indispensable part of the normal management of childbirth. And in developed countries, most women are given oxytocin to help facilitate childbirth, to aid the expulsion of the afterbirth, or to prevent postpartum hemorrhage. And this is a clinical literature that you'll see kind of splinters off into tendrils that reflect slightly different treatment strategies for different complications and evaluating their safety. Now, network visualizations are fun, but we don't tend to actually work from them. Here I just show you the percentage of each cluster's references that are directed either at itself or at other clusters in this network. So I'm only counting the connections between the nodes in this particular network as well. So as you'll see in the kind of green box here, all clusters direct the largest proportion of their references to papers within their own clusters. We see some clusters are slightly more insular and some are more outward looking. For example, where is it? The receptor cluster. The receptor cluster is more interconnected than lots of the other research areas, and this is it's a central literature to pretty much all the areas here. Other literature such as reproductive physiology or obstetrics are comparatively insular. So we see here that oxytocin research is composed of quite a diversity of subcommunities that are interested in quite different things. They cluster together densely with sparser links to other related communities. And this means that evidence and ideas and methods and understanding circulate primarily in specific communities pursuing specific questions. And there's nothing really surprising about this. This is exactly how you would think science should work and how it does work. But it does have implications for how papers are cited. So here we see the mean citation impact of papers in each cluster. So this is calculated by considering the total citations to these literature as recorded by the Web of Science. We can see it varies quite considerably from cluster to cluster. So here are the mean citations. I've also calculated the mean number of references. The age of the papers here is the median publication date of papers within a particular clusters. This is the number of papers within a cluster. And this tells us the percentage of the total citations to a particular cluster that are explained by my oxytocin papers. And so we can see that we can kind of see from this that papers at different ages tend to have different mean citation counts. Older literatures have a lower mean citation impact, which is related to reference list sizes. We can also see each cluster varies in its mean reference list size, calculated by just the total number of references in each paper. And generally, the larger references, the larger the citation impact of a literature, because this means that if you have if you've got a population of papers with a larger mean reference list size, then there are kind of more opportunities to send out citations to papers. And we've just seen that papers tend to cite other papers on the same or similar topics. And so you can kind of see they're a little bit surprising here. The kind of mean references and the mean citations are kind of converged for the older literature. They're about at the same level. The newer literature's probably not had quite enough time to be cited yet to kind of equal that out, which I'll go into in a little bit. Now, does the difference here in citation impact reflect any kind of bias? Obviously not. The mean citations of a body of literature will reflect how many people are publishing papers on that topic, and the size of reference lists and so forth and so on. Where a bias will emerge, however, is if you compare the mean citation impact of a different research topic to other research topics, and by extensions, the citations of one paper on a particular topic to a paper on a different topic, and to use these metrics as some kind of indication of quality or importance. That would be not the metrics kind of being necessarily biased, but you'd be using them in a biased way because they're measuring different things, different dynamics in different literatures, despite the fact that they will superficially look like they're working on oxytocin. And sometimes it can be unfair citations. So sometimes the literatures that you think should be highly cited aren't. And this is probably most strikingly highlighted by the relatively low citations to the obstetrics literature. And this is a literature focusing on probably the only thing that oxytocin is definitely useful for. Arguably, it's most important literature, but it isn't opening up really new questions for theorists, but rather it's translating basic understanding to help improve healthcare. And perhaps for this reason, it loses out in the citation game, perhaps. Now you might think, well, I hope nobody's thinking this, that, well, oxytocin papers have a very impressive mean number of citations. Few of my papers have ever been so often cited. Maybe I should move into oxytocin research. However, the vast majority of these oxytocin papers haven't been cited anywhere close to the mean number of citations suggests. This is because citation distributions are very heavily skewed. And to the figure to the left here, this one here, I've plotted the percentage of papers on the y-axis that account for a given percentage of the total citations in 6 of the clusters. I haven't inserted the 4 most recent clusters by median publication date because these haven't really had enough time to be cited yet to measure this reliably. Now, in all of these 6, we find that about 20% of papers accumulate about 60% of all citations. Distribution is remarkably consistent. The lines here basically sit on top of one another. It is ridiculous. This suggests, or it's been taken to suggest, that there is a strong and kind of uniform selection pressure on the literature, and that determines how, in all fields and at all times, just a few papers will be disproportionately influential. This is understood to reflect cumulative advantage. Papers that are frequently cited are more likely to go on to attract more citations than a paper with fewer citations. And there's also Martin's sociological explanation of this, which is the Matthew effect, which proposes that papers with well-known authors and or papers in journals with a particularly high reputation are more likely to be noticed and cited. But also, if you think about it, papers that are cited more often will simply be noticed by others during the course of their reading, and this will increase the probability that they will get the opportunity to be cited. Now, I won't go into these details here. I'd really recommend just reading these papers. They're beautiful. So, and they say these things a lot better than I can. Now, another stunning regularity of the literature is the tendency for papers to reference other papers published in close temporal proximity. And here I've plotted the total references from papers in each decade of oxytocin research from 1950 to 2019. We see that these papers are most likely to reference papers published 2 years previously. So here we've got the total references and then the age of those references along the x-axis, and in every cohort here most citations most references are 2 years old. So this tells us that these papers are most likely to cite papers published in the last 2 years, if they're going of all the years that they could be referencing. And here is just a proportion of the total references against the age of references in each of these. So what this means is that the kind of probability of being cited depends heavily on the growth of literature on your topic or related topics in the years immediately after publication. Now, again, is this a bias? Probably not. Now, it seems reasonably sensible that papers cite recent papers because research areas are ongoing debates about how things are and why they work. So there is a need to engage with the most recent positions. Of course, this doesn't mean that all papers' citation histories follow this particular trend, but it just means that on average, this tends to be what happens. But this does mean that if you compare the citation metrics of literature published at different times in different research areas with different growth rates as some measure of quality or importance of that literature, then you will be descending very slowly but surely into nonsense. Now you'll see that actually the last two, 2010 to 2019 and 2000 to 2009, the reference lists are actually getting a little bit older. And the 2000 to 2009, we can explain this because of a dip in publication, which means that papers started to kind of force to cite older literature. Whereas this decade, the most recent one, is a little bit of an anomaly, and I'll get to what's happening here because I think it's quite interesting. Now here I've just assembled a few figures that will kind of emphasize the impact of literature growth and reference list growth on citations to this particular literature. A shows the number of papers published in each decade between 1960 and 2019. B shows the growth in mean reference list size. The average size of reference lists seems to have a direct influence on the number of citations that papers receive, and it's been increasing over time. So Oxytocin papers in 1960-69 refer to about 19 other papers, while Oxytocin papers in 2010 to 2019 refer to an average of 59. Now figure C shows the mean number of citations to Oxytocin papers published in each decade between 1960 and 2009. Within 10 years of publication. So to measure this, you take all the papers published in 1960 and look at how they've been cited over the next 10 years. You do this for 1961, and this is what this figure is measuring after aggregating these into particular decades. Now, the blue bars are the means, the red dots are medians. And you'll see that there's quite a discrepancy every decade. And in figure D here, which shows the mean number of citations received by the top 10% of papers in each decade, and in blue here. So this is the top cited literature's mean citations, the top 10% of papers. And in orange here, I have put the mean number of citations of the remainder, so the 90% of other papers. And you'll see this is kind of heavily skewed, and it's becoming even more skewed. Skewed as the literature is growing, the reference list is growing. This increases the kind of seeming to increase the skew here. In figure E, I've plotted the total citations to articles in each of the 10 years following publication for papers published in each decade. We see just how extraordinary the 2000 to 2009 was, as it really isn't conforming to the other decades at all. So what was happening here? So in the last 30 years, a large literature has grown on the theory that oxytocin is released in the brain where it has pro-social actions, promoting bonds between individuals, alleviating anxiety, and enhancing empathy. So it's a theory that, from its origins in animal studies, has really attracted considerable scientific and media attention. And about 15 years ago, a paper in Nature reported an effect of intranasal oxytocin on interpersonal trust in humans. And with 2,022 citations as of February 2021, this is now the highest cited paper ever published on oxytocin. Now, it wasn't the first paper to use intranasal oxytocin, and this is spraying oxytocin into the nose. And this intervention had been used by obstetricians in the kind of 1960s, but it kind of fizzled out of use. A few papers in the 90s were using it, notably to try and treat obsessive compulsive disorder, but interest fizzled out again after a few unsuccessful trials. But what was novel about this paper was that it extended the use of this peculiar intervention to study trust in humans. And to do this, they made use of a trust game with monetary stakes where success requires the player to develop trust in a playing partner. And there was nothing particularly new about the trust game either. It was if you're a behavioral economist, you'll know it well. But the combination of spraying oxytocin into the noses of players and this captured people's interest and imagination, that a kind of simple and cheap intervention could be used to study human social behavior. This was very quickly joined by several other highly cited papers, each attracted more than 700 citations to date, and they arrived at kind of similarly bold claims that intranasal oxytocin might reduce stress, that it might enhance the ability to infer mental states and emotions via reading social cues from the face, increases generosity, as well as other studies reporting effects on trust. And these established intranasal oxytocin as a hot topic, and a cascade of papers followed in high impact journals, which strengthened the perception that this was a high impact field with a potential utility in treating conditions such as autism, schizophrenia, anxiety disorders, and post-traumatic stress disorder. And in figure A, you can see the kind of massive rise in publications in red, and it's along the y-axis, and the rise in citations in the secondary axis here by year. And in figure B here, you see the history of oxytocin research that I showed you earlier, and in the red line. And if you exclude the intranasal papers from this history, you get this yellow line. So much of the recent growth in oxytocin research has really been explained by the massive popularity of intranasal oxytocin research. Now, there's been about 1,400 intranasal kind of papers published between 2000 and 2020, and these have collectively been cited about 52,000 times in about 14,000 papers. Again, about 23,000 of the references within these papers are directed at other intranasal papers, so about 44% of the total citations are accounted for by other intranasal papers here. And this isn't surprising. It's kind of fast-moving research front that is kind of intensely interacting with one another. But about 90% of papers here reference one of 10 very highly cited papers, and these were all published before 2011. And each of these kind of reports very promising, kind of interesting results with intranasal oxytocin. So the bibliometric record marks the Cosfeld paper that I've just shown you with the trust game and intranasal oxytocin as a kind of study of exceptional impact. And it was part of generating interest that pulled many new researchers into this area. And now you might assume that such a highly cited paper must be methodologically robust, with firm findings upon which others then build their research. This doesn't seem to be the case for the highest cited paper in oxytocin's history, however. In 2020, a pre-registered double-blind placebo-controlled trial failed to replicate the results. This study was even included actually one of the original authors. And so it's the kind of gold standard of replications to actually include a member of the previous team. This field is now and it has been in a bit of a controversy of the reliability of intranasal studies, and controversies are kind of ongoing, so we don't really know what's going to happen in this field. From a sociological perspective, it's a kind of fascinating area, particularly because some of the new figures in the area, and then such as Dan Quintana, who's given a talk at RIOT, are kind of really doing a huge amount of work to improve the reliability of this area. And so it's a little bit of an open science revolution, perhaps. Okay, so what can we make from citation metrics from what I've just shown you? Well, I hope that I've made the case that citations might have something important to tell us, just not what we perhaps wanted them to. And so to just briefly summarize, before thinking about citation impact, we really need to consider that papers tend to reference other papers that are directly related to a particular research topic. The papers tend to direct the majority of their references to papers recently published, and that papers tend to direct references at papers that are already cited by others. all of this is kind of obvious, but it's worth saying since we've imbued citation metrics with magical properties. These factors mean that a paper in any given area will be cited more heavily on average when the literature on their topic grows in the immediate years after publication, especially so if the reference lists in sizes increase. Paradoxically, though, if you think about it, the pressure to publish on particular hot topics seems kind of destined to eventually produce literatures that are kind of on average very poorly cited. Or if you think, so when a subfield grows rapidly, the number of potentially citable papers will begin small, and so these will enjoy a kind of massive citation advantage. But soon, the kind of number of potentially citable papers will exceed the number of citation opportunities afforded by reference lists. At this point, reference selection becomes increasingly constrained by the perceived need to cite established totems, so the well-recognized papers within a field, and the kind of desire to grant priority to particular papers for particular discoveries. And this kind of collectively will give give less space to cite more than a few of the abundant new papers. And so this doesn't mean that the new papers are bad papers. It just reflects that literature just maybe in a slightly different phase of their growth. Though for some reason people take these metrics as meaning something that they just don't measure at all, which is quality. Now, many professional scientists warned against the use of article and research level metrics, but I wanted to show you all of this because I suspect that while we know metrics might be problematic, we probably use them more than we should as researchers. Now, from my experience, academics, we generally suspect the misuses to which citation metrics are put. However, they generally still pay close attention to their own citation metrics, and they're kind of keen to know that their own work is being noticed. I think that's why they do it. It isn't uncommon to see people listing still today the total citations to their works on their websites or their CVs, and they're worried, and I hope that academics don't use this, but the fear is that some academics might be using citations as a proxy for what is worth reading, or influencing their perception of the quality of studies. Now, I know my students definitely do this, and it is hugely problematic. And it's hard to explain to students that just because a paper is highly cited, it doesn't mean it's a good paper. It's kind of the image of citation metrics, and I guess we're all kind of complicit in it, why students might get confused by this. But if you think about what the attention by researchers to citation metrics, just think about the assumptions that it embodies for researchers to kind of take citation metrics seriously. So to use the counts of their papers as a kind of measure of their impact or the quality of their work. Now, this attention must embody a few kind of basic assumptions, and these include that a paper which is cited has been read by the person who cites it, and that it is cited for what it says, not for what it is assumed to say. That it is cited because it is better than competitors, and so it is assumed other similar papers have been read for it to be compared to, and that it had some kind of influence on the work of those who cite it. But are any of these sound assumptions to actually make? And so now we turn to citation bias and distortion. Now, metrics are one problem, but another quite different issue is how we actually reference literature in our papers. Now, most will be aware that papers reporting positive findings seem to be more likely to be published. So this is publication bias. But it also seems to be the case that they are more likely to be cited. Indeed, it has been proposed that the apparent citation advantage enjoyed by papers reporting positive findings is one of the major driving factors behind journals preferentially publishing such studies. And this is supposedly because they have a desire to inflate their impact factors. And this is another piece of nonsense that I won't go into here at all. Others have done it much better than I'm going to do it here. But what you need to know if you're going to place any weight on citation metrics is about the positive skew to citation. And so Daniel Finelli, in a great little study in 2013, looked at 2,600 hypothesis testing papers published between 2000 and 2007. And he found that papers reporting on positive outcomes had an average of about 32% more citations than those that did not. And this did vary between disciplines. And in figure 8 here, I've taken one of the figures from his papers and read it. And this is why I'm not going to define these for you. I hope that you do read the paper. But here, I'll define one. This is psychology and psychiatry, and by Finelli's results, more than 90% of the papers in psychology and psychiatry had reported positive results, and these enjoyed about a kind of 50% increase in their citations compared to the papers that did not. So obviously, you need to be aware of this if you're assuming that the citation metrics tell us anything about quality, out of fear that I don't think I don't need to explain why it's problematic. But this study by Finelli is not directly measuring citation bias. The results don't demonstrate that any particular claim is necessarily being distorted by a biased selection of evidence. But what it does show is that if you think about it, if literatures grow on the basis of seemingly supportive findings, those papers that are at the beginning of that huge surge in growth are going to benefit disproportionately from it. But what is probably worth reflecting on is, what do you think happens to a paper that falsifies a hypothesis? Or now I've published a few papers on this, and one of the chapters of the book goes into this. But if you think about it, if you publish a paper in a particular research area that kind of clearly demonstrates that a particular question or particular technique is definitely wrong, and it has the impact that you want it to, then that paper is probably not going to enjoy high citations. Because if it has the impact it wants, its impact should be seen by the collapse in publications on that topic. Because what's the point in publishing on topics in which we already kind of have a good understanding that it's not a kind of hopeful direction? So Finelli's studies isn't a direct study of citation bias, but it does give us a kind of probably the best study that we have about the kind of tendency for scientists, the citation metrics to be skewed to positive results. But other studies have directly investigated citation bias, which is preferentially citing evidence of a particular direction while ignoring inconvenient evidence in reference to some specific claim. So in 2017, Bram Dux and colleagues performed a meta-analysis of the then 52 studies of citation bias, and 38 of these focused on bias in the biomedical literature, 7 in the social sciences, I think it was, and 6 in the natural sciences. Of these, I think it was 29 reported no clear effect of the outcome on citation. 29 reported a clear effect of outcome on citation, while 11 reported no effect at all, and 12 had mixed findings. The authors concluded from their meta-analysis that positive articles are cited about 2 times more often than negative ones. And our results suggest that citations are mostly based on the conclusions that authors draw rather than the underlying data. Now, this wee team by Bram Dux and I think Miriam Erlings and colleagues has actually published quite a few papers on citation bias since this, and I really don't want to step on their toes by presenting any of their recent stuff. So I'll put a link to the paper or two in the kind of bibliography, and it might be fun to get them to present on their work. So before quickly going on to citation bias, I kind of want to make a distinction between the act of being biased and what we mean by citation bias. So I'm just going to call the act of preferentially referencing evidence that supports a particular claim, say fish causes diabetes, while ignoring inconvenient evidence to that claim is a biased selection of evidence. Now, referencing biases can refer to the selective use of particular studies that support a claim you want to make, but it can also describe the selection of particular supportive findings within the body of a paper, for instance. Now, from paper to paper, a biased evidence selection might not be necessarily problematic as long as you make your own biases clear, and it also depends on the intentions of what you're trying to do in a particular paper. We all have our own idiosyncratic biases, and we should always be aware that however hard we try and minimize these biases, we're probably going to fail quite a lot of the time. As long as there are our own biases and we are not copying evidence and interpretations from others, I think there is probably room for a certain amount of a little bit of bias in certain circumstances. But citation bias means something quite different, and it describes a significant difference between the citation counts of papers that have contributed evidence towards some specific claim. And this bias must favor results of a particular direction, and this bias must persist after considering other relevant methodological aspects of the target studies. For example, study design and quality, sample size, the synthesis of findings from each of the studies, whether studies report other findings and whether they are cited for these, the year of publication of the particular studies that you're looking at. And this is a bias that describes a skew across a literature, and it increases the danger that a field's understanding is based on dodgy foundations. And this is what the next case will demonstrate. So citation bias really received kind of comparatively little attention compared to stuff like publication bias until a neurologist, Stephen Greenberg, published a study in the British Medical Journal in 2009 documenting its detrimental influence in his field. And Greenberg had become interested in whether a claim that he had seen regularly in scientific papers was actually supported by the evidence. Now, it was widely known in his field that a particular protein, beta amyloid, was abnormally present in the muscles of patients with inclusion body myostases. This had important implications for treatment, and hundreds of papers had given the impression that this was a fact, and he wanted to find the evidence for it. But Greenberg could only find 12 papers that had investigated this claim directly. Of these, 6 supported it, but 6 did not. The first 4 supportive studies came from the same laboratory, and these had clear technical weaknesses, and 2 of them probably reported mostly the same data without citing each other, at least according to Greenberg. So Greenberg wanted to understand why this claim, which to him now seemed dubious, had been taken as a fact. And he looked at how the first 11 primary studies, all published between 1992 and 1995, were cited in the years until 2007. 6 unsupportive and 5 unsupportive studies. He found 242 papers that made specific claims about the presence of beta amyloid in patients with IBM. He recorded all the citations from one paper to another in this set to understand the interactions between them. He then classified every citation as being either supportive of the claim, neutral to it, or critical of it in a claim-specific citation network analysis. From this, he constructed a citation network, and it looked like a typical citation network with a heavily skewed distribution of citation. A total of 214 citations were directed to the early primary studies, but 94% of these were to the 4 supportive studies, while only 6% were to the 6 unsupportive studies. The literature was overwhelmingly, it seems, citing supportive evidence while neglecting unsupportive evidence. So how did this happen? Greenberg analysed how the trial evidence might have spread from paper to paper by tracing the citation links between papers. With this, and this is his network here, which is it's not the best graph. With this, he showed that review papers had kind of played a major role in directing scientists to the evidence. Knowledge about beta amyloid derived from 4 reviews, 95% of all paths, and these are chains of citations that string papers together to the original primary data, went through these reviews. These reviews cited the 4 supportive primary papers, but none of the unsupportive studies. They had acted as these kind of giant lenses, focusing attention to studies that supported the beta amyloid claim. Now, with this, Greenberg had shown that citation bias can lead to distortions in scientific understanding. The decisions of individuals to cite only certain papers seems to have consequences that ripple through the literature as scientists draw from or find evidence from evidence that's been previously cited by other papers in their own literature. Now, if you want to do a claim-specific citation network analysis, I put this slide here, but I'd really recommend, so you can go back and look at it, but I'd really recommend that you read Greenberg's paper. It's a kind of wonderful paper, especially the supplement, which from my experience nobody is actually reads. And I read this paper first in 2015, and it kind of had the biggest impact on me that any paper ever has had. And I applied to do my PhD because of this paper, and it remained the most important study for me really throughout my doctorate. So yeah, I've been working with this method for 5 years or so. So in 2018, I extended Greenberg's claim-specific citation network analysis to understand the propagation of evidence for the hypothesis that saturated fats have a causal role in heart disease. Now, between 1965, so I'm a sociologist and historian of science, so I tend to be more interested in the older literature. This is why I'm looking at old controversy here. So between 1965 and 1968, 4 RCTs tested whether diets with a lower fat content would benefit patients with heart disease. So secondary prevention of heart disease. Now, by 1984, these were still the only published RCTs to test this particular intervention. In that year, as some of you will know, a consensus conference of experts concluded that elevated cholesterol is a cause of heart disease and that reducing fat intake would benefit patients with heart disease. So I wanted to understand how these 4 secondary prevention trials were cited in the period up to 1984. And these 4 trials were, at the time, the only direct evidence about the effectiveness of dietary intervention in such individuals. One of these trials, which was the Oslo study here, had found lower levels of heart disease in the intervention group, but the other 3 had returned negative results. Now, if you take the 4 trials together, there was no significant effect from the lowering of fat intake on the hard clinical endpoints, the incidence of myocardial infarction, fatal heart disease, or all-cause mortality. Now, of these 4 trials, the Oslo study and the unsupportive study of 1968, this is by the Medical Research Council, were the largest and longest, and both of these had quite similar sample, they were the same size, and very similar protocols. And it's very hard to make a case that the Oslo study was more authoritative than the MRC study. These are the 2 studies here, which were negative trials, were smaller, but I put them here anyway. So by 1984, the supportive trial had accumulated 259 citations, while the most highly cited unsupportive study was cited just 60 times. Now, this is kind of a unique case because they're all published within a couple of years of each other. So it represents a kind of great case to follow up how these studies were used, and especially because no other secondary prevention trial, no secondary prevention RCT was published up until after 1984. And so I wanted to know, following Greenberg, how reviews were citing these studies. Between 1969 and 1984, 62 review articles discussed at least one of these trials. Of these, 28 drew conclusions in support of dietary intervention, 17 were neutral, and 17 were unsupportive of it. Now, of these, 28 were published in the first 7 years, with 12 supportive, 12 neutral, and 4 unsupportive, and 34 in the next 8 years, with 16 supportive, 5 neutral, and 13 unsupportive. So it actually became more polarized over time. And so I constructed a claim-specific citation network in the same way that Greenberg kind of described. And I wanted to see if reviews that came to a different conclusion on the effectiveness of this treatment were citing the same or different studies. Here we see the neutral reviews. And these are reviews that come to no clear conclusion. Basically, when they were discussing the evidence, they just simply highlighted that the evidence for this intervention is currently conflicted. And these tended to cite in a very balanced fashion. And here along the middle of the graph here are the neutral reviews, here are the negative RCTs, and here's the one positive RCT. And you can kind of see quite easily and visually here that these reviews are being quite balanced in how they cite. There isn't really any prominent citation bias here. We've got one paper here that only cites the supportive RCT. So here are the critical reviews. Now we see the critical reviews, and these were reviews that declared that the existing evidence did not support the use of such treatment. Now, the Oslo study and the MRC study were each cited about 12 times in this, so they're kind of balanced in that sense. But here we see that kind of 5 of the critical reviews cited only evidence that supported that conclusion. And you actually had 3 studies here that only cited the Oslo study, and these had a different interpretation of the meaning of these findings. So they were reinterpreting this as not supportive. This is the supportive reviews. So things got a little bit worse. In 23 of the 28 supportive reviews, they only cited the Oslo study, which was a single supportive study, and only 5 of these reviews cited any of the other RCTs. But to be fair, some of these were kind of consensus reports by the AHA, so they did a good job here. But this is a kind of massive bias. That means that the conclusions of these reviews were based on drawing from only the evidence that supported that, while just ignoring the evidence that didn't. And in this study, I found that a high proportion of the reviews cited only very few ever cited all the available RCTs, and this is slightly surprising considering there was only 4 such studies. So you'd think that it would have been quite easy just to kind of note that there had been 4 different trials and explain why some were stronger or weaker, but this didn't happen. Now this is research. I realize I am probably approaching time here. And research underutilization is related to this. I'll put a reading on it in the slides at the end. So I'll end on a kind of lighter note because we all need that. It's Tuesday. So this is citation distortion. This is a term used to describe when a study's conclusion or findings are distorted by flawed referencing or erroneous citation. So in 2010, Andreas Stang published a critique of the Newcastle Ottawa scale, and this is a scale that is used in meta-analyses to assess the quality of observational non-randomized studies. And he came to a bluntly critical conclusion in this commentary. I believe Wells et al. Provide a quality score that has unknown validity at best, or that includes quality items that are even invalid. The current version appears to be unacceptable for the quality ranking of both case control studies and cohort studies in meta-analyses. Now, that seems to be a kind of unequivocal critical conclusion. It's a commentary. Now, this commentary was cited a lot, as the kind of citation history that you see here shows. It's been cited 6,000 times as of today. And this is very surprising for critical commentary. This would probably make it one of the most cited critical commentaries in the history of publishing. So Stang was a bit confused by this, and he actually followed it up. So 8 years later, Stang and a few colleagues published a second paper calling attention to the widespread inaccurate citation to his original commentary published in 2010. Now, in the intervening years, Stang had somehow become the go-to reference for scientists seeking something to reference when they use the Newcastle Ottawa scale in their publications. And so to ascertain this, Stang actually did a little network analysis and a little claim-specific analysis. And in a sample of 96 citing systematic reviews, Stang found that 94 cited it in a manner that suggested that it was supportive of the use of the Newcastle Ottawa scale, despite the fact that this is opposite to the argument he made in that particular critical commentary. And in only 18 of these systematic reviews did they provide an additional methodological reference. Now, I think it's always worth kind of reflecting on this. What would you do in this situation? You've just authored a paper and it's skyrocketing in citations. Would you ride the citation wave straight into tenure, or would you call out the problem? Stang definitely did the right thing here and wrote a great little paper challenging how his paper was being interpreted. But I think it was a brave thing to do. But it seems that perhaps his follow-up hasn't really been paid attention to. So these are just two recent citations to that original commentary of Stang 2010, and they are still using it in the same way that Stang was criticizing. Now, I haven't done a systematic study on this. This was pretty much the first two papers I found. And considering Stang's 2010 paper continues to be cited at a staggering rate, how many of the citations to this paper do you think are still citing it wrongly? Now, the attempt by Stang in his 2018 follow-up to combat the spread of the kind of erroneous interpretation of his work seems to be falling on deaf ears. So his own analysis of the misquotation has been cited only 13 times, according to Web of Science. Now, unbelievably, I checked this for this talk, I actually looked at how some of the papers were citing his paper, calling into question the kind of misquotation of his 2010 study, and they seem to be citing this in the same erroneous fashion as they were his original paper. So here they are, and I have no idea what's gone on here. It's unbelievable. Now, it seems sometimes, I think, a paper is cited not because of what it says, but for what it is believed to have said, even at the protests of the authors. But if none of these papers have read the paper, and there seems to be a reasonable guess, then why do they reference it? That's the final slide. Should I do this? No, I won't do this. I've got a blog on this, so you can read about the phantom reference. And this was discovered by someone else. This was a fake paper that kind of became associated with a particular empirical claim. So I won't do that. So to kind of summarize, what's the take-home message? Citations are not a proxy for study quality. Regarding them as such is both distorts and is distorting of scientific understanding. You cannot take the description of previous findings or the references used to previous studies in other scientific papers as necessarily an accurate account of the existing evidence. And importantly, you need to be aware that authors can and do selectively cite the evidence that supports their preferred interpretation. So if you're just following the papers that an author cites, you will tend to find the literature that supports the author's position, and you may miss the inconvenient evidence. Now, that's quite enough from me about the problems in science for now. I hope I've made the case here today that publication and citation data might have quite a lot of stuff to tell us, but just not what we perhaps expected them to. Before I cut the slides, here's our book. It's not really a book about citation problems. It citation problems are 2 of maybe 25 chapters of the book, so there's a lot of other stuff in there. Here is the review of our book by my 7-year-old little brother, and if you can't read it, it's probably the harshest review ever. It says, "My little blah blah book that doesn't mean anything." So I really hope that he doesn't ever become an academic. And this is Gareth, and he'd very much like to be here today, but COVID restrictions are making things this very difficult at the moment. So that's quite enough for me for today, and I'm happy to hear your thoughts, and I really hope you enjoyed it. If you kind of have any follow-up questions, do get in contact. So that's me.
Wonderful. Thank you so much, Rhodri. Brilliant talk. Really crystal clear and packed with things. Ian and I have been sort of fangirling in the background at how we've sort of had a huge like geek off, I guess. I have to say, I really want to know what this phantom reference thing is, but if you want to continue to tease us, that's fine.
I could quickly tell you about the phantom reference.
Go on. Go for it.
And you don't even really need the slides for it.
Okay.
So this was a fake reference that was discovered by Peter Kroonenberg and Anne Harzing, and it was an example reference that Elsevier had used as a kind of style template to show authors how to reference papers, but not to actually include in papers. But it's been cited 400 times. Now, most of the citations to this phantom are actually from meeting kind of abstracts, and the likely explanation is that they just forgot to remove it from the template. But because I'm interested in citation dynamics, and because I know that you have this tendency in the literature to see this citation copying, where people borrow citations and the interpretations of those studies from the papers they read, I thought, well, I bet this is spread. So I looked at it, I just made a network, and in that network, you have a kind of little cluster of 13 papers that cite each other. And that was a bit weird, right? The probability that you'd have the papers, all these papers forgetting to doing the same error, but also citing each other. And so I read each of those papers, and in those papers, the phantom reference had come to support a claim that the compound rutin has particular health benefits. And I've got a blog on it, and you see this claim. Actually, people begin to add to it. So the kind of health benefits of rutin by the end of this chain have kind of spiraled. And the irony is that the fake title of the phantom reference is The Art of Writing a Scientific Paper. So it is just, it's a wonderful story. Why it happened, I don't know, but yeah, I think it's a funny little thing that happens in the literature, and I think it's a good reminder that sometimes we can't take citation metrics too seriously. I mean, if a phantom has been cited more than probably a lot of people's collective citations, then they probably don't mean a lot.
Yeah. It's funny, when you were speaking, it reminded me of a paper called Academic Urban Legends by Bjorn Rekdal, and in it he goes through a huge sort of journey of getting to the bottom of the have you heard that this association with spinach and iron, and it was due to a misplaced decimal point, but apparently that's the urban legend. It wasn't actually a misplaced decimal point, and people had cited it, so it became sort of this meta citation where they were citing this article that actually itself was incorrectly saying that it was a decimal point error, and it was just magicked out of thin air, that it was just people just citing one another for convenience, and it got the kindling going. I've got a couple of comments in the Q&A, and Ian and I have collated a few ourselves, but we've got a couple from Sarah C. One is a comment, and Sarah says, not necessarily a question, but just a statement. So glad you decided to focus on oxytocin research. As someone who has conducted research on social bonding, the overabundance of research on oxytocin has particularly irked me. Kosfeld, which you mentioned, and Zach are two of the most cited articles. However, these have been criticised by so many reviews of the oxytocin literature, and she lists a few in the comment. The latter two, Naive and one by Bakersman's Cronenberg, conducted meta-analysis and found effect size is not significantly different from zero. And as you mentioned, registered replications have failed to find similar effects. Thanks for highlighting this. Sarah also says something else, which is, thanks for an interesting talk, Rhodri. What do you think we as scientists can do about the propensity for misciting, as you've shown in the distortion of meaning slides, or citation bias for positive/supportive findings?
So thanks very much for the comments. I think the intranasal literature is kind of fascinating at the moment because it's kind of going through this controversy, and as a sociologist of science, this is the kind of stuff I'm very interested in. I'm interested in how we come to agreements on the kind of what the evidence supports and what kind of drives controversy. And it's and I think it's the only reason I kind of wanted to talk about the intranasal was just to show this dynamic of a kind of exploding literature. It's not really my place to make kind of comments at the quality of this. I need to do a bit more research. If somebody wants to fund me to do the research, then I definitely take a look at intranasal oxytocin research. But yeah, I wanted to show that this kind of cascading, this kind of pile-in of papers means that you get this massive citation impact for the first few papers, and that it's going to kind of tail off as you get more people in, and it reaches a more kind of stable state. But yeah, thanks for kind of highlighting the other kind of papers on this. What can we do about trying to stop citation bias and the spread of error? Well, I think we can read papers. I think that as much as, you know, we like to blame incentive structures for lots of problems in science, and I think they're huge problems, but a lot of problems is maybe the pressure of time. We maybe just need to get a little bit more careful with what we are saying in the scientific literature and spending more time reading again. Systematic searches, obviously, and systematic reviews are going to be really important for stopping stuff like citation bias. So if you're just finding studies via Twitter or by word of mouth or by reading the other literature in your field, then you're likely to kind of replicate any biases that are in any of those particular systems. And so doing a kind of systematic search where you use a kind of very clearly defined search across lots of databases for the studies that interest you should stop citation bias. But I guess it's, you know, if you speak to lots of people about how they reference, a lot of people I know write the paper and then reference it. And so they then search for the evidence at the end, which might be a problematic practice if you think about it. If what you've said didn't really depend on the reference, then why bother referencing?
Mm-hmm. Yeah, it's two things that you've sort of preempted questions from Ian and myself. Ian has a sort of practical question, which is, are review papers excluded from the citation analysis? The growth in these recently may obscure the number of experiments.
So they're not from that. The difficulty with Web of Science, with articles and reviews, is that the classifications of both of these are not always as precise as you want. And I kind of wanted to I didn't want to have to explain a kind of strategy of exclusion here. And the difficulty is that reviews are becoming evidence in and of themselves. So meta-analyses are not just kind of collections of surveys of a literature, they're also producing new findings. And I know the intranasal oxytocin literature has a huge amount of meta-analyses, but these in part are not just summarizing the available evidence, they're also producing new evidence. the synthesis, if that's cited as the kind of support for a particular claim, then it becomes the kind of focal point. So yeah, I haven't done that there, but I think there's good reasons for keeping reviews in or excluding them. But yeah, I think that the number of reviews will have a kind of certainly inflated the number of intranasal oxytocin studies that you see, but not by a huge amount. If you can rely on the Web of Science classification, at least. I think it was about 5% of the papers, 5 or 10%. I can check though.
Yeah, it's interesting what you said about this sort of retrofitting the references after finishing the paper. So have you ever been tempted to see if there's a relationship with citations and papers that appear in sort of the top half of the Google search?
No, but I know somebody else has done this.
Right.
I saw it at a conference. I don't know if the paper's ever been published. I'll try and find it for you. But yeah, I think all these systems are going to affect us, right? This is just how we find literature. And my research is, I'm more interested in how we form kind of our understanding than I am about bias so much. But if you think about it, we have to find evidence somehow, and our memories work in this kind of strange and selective manner, and our attention's limited. And so I have no doubt that positioning papers in Google search results by the total number of times cited is probably going to cause problems. Like I set my students a task, which is that they have to do a policy brief on a particular intervention. So they have to go out and they have to review some evidence behind that intervention. And so they have to go and search for the literature themselves. And these are always the most terrifically biased pieces, because they're typing into Google Scholar does X causes Y. And so they go and find all the literature on that. And the first paper that comes out is obviously a paper that normally has that particular positive connotation in the abstract or in the title, and it's the most highly cited.
Just another couple of questions have come through. It reminds me of a Everything Hurts podcast, and they were talking about the use of Wikipedia, and I forget the details, but there was a comment that was made that obviously one of the first things that students do is go to Wikipedia, and wouldn't it be great if you introduced an error in the entry of Wikipedia, and then you can quickly see who's using Wikipedia. Hannah,
you can actually do that on your lecture slides. So you can give a little fake kind of, you can see it, and I might have tried that before, but I don't want to give it away, because if you give your tricks away, then the students know, and they'll start to game the system. So you normally tell them at the end.
Hannah has a couple of questions. Her first is, love the talk. Related to the phantom reference, have you ever looked at citations of fake articles? There are a few AI generated papers that have been published as actual papers, and I wonder what their impact might be. Do you want to have a go at answering that one first?
Well, that's really interesting. If anybody actually has anything they want me to follow up, I'm always on the lookout for kind of interesting cases to follow up on. But no, I haven't really looked at this. As I say, I'm giving a talk today about bias and error, but this topic actually depresses me. It starts to, you can only work on it for so long before you start to wonder why you're doing anything. If you get the impression that no one reads your work, and you may as well just be publishing fake papers. And I don't want to believe that, and I don't think it's true as well. I just think that citation metrics make us think that that's what's happening. But no, if you send me these papers, I'll definitely have a look for you. That sounds fascinating.
And the second comment is a small comment question. I heard that in news publishing that fake facts published by an unreliable source can become considered as true due to circle referencing and the original article later updating their references makes you happy that you can't change the references after an article has been published in the scientific literature. If you've got nothing to say on that, I think it was more of a comment than a question. I have a few more questions and then we can probably wrap up. But one is, could citation network analysis be useful for identifying which papers to replicate?
Yes, I think so. I like citation networks, and I think that they're actually very useful for finding literature. So I've only shown you the very simple versions of them here, but you can grab, say, a literature that you're interested in via a systematic search query, and then look at all the papers it references. So you can have a sense of what is the literature that's being most cited within a body that you're specifically interested in. And if nobody's replicated some of the kind of core papers there, then that's a really important thing to do. You know, it might be the fact that actually, as kind of Greenberg's study shows, is that actually it's sometimes worth going back and saying, does the primary data actually support what we're trying to build? And I think I think you're seeing that with a lot of replications in the social sciences at the moment, is that we've built kind of large frameworks of understanding on foundations that don't seem to be as solid or non-existent in some cases. So it's I think you could use citation networks in this way.
And
I probably need to publish a paper on it.
Yeah, I think so. I think, I mean, I'll try and bundle a few questions together. I sort of have a question on, you know, if you wanted to do to the audience, you know, what resources or things that were useful to you when you ran the network citation network analysis, and any things you can signpost to people that might want to do it themselves?
Yes, so I run a course at Edinburgh on systematic review and citation searching, and part of that is citation network analysis. So I've kind of stuck it in at the end of the course, and so I'm more than happy just to send my lectures over and the course material. So if you're interested in it, just get in contact.
Wonderful. Great. We had a question from Ian as well, which was, what was the characteristics of, well, it's a general question, which is the characteristics of the top 10 cited papers. So looked at positive versus negative mentions in citations.
So it tends to be the case if you look at a literature, the ones that I've looked at, the kind of core literature in an area will be ones that open up new questions, and typically that's, if you think about it, why do papers get cited? It's because other papers follow them up, right? Now, if you publish something that shuts off a question but doesn't open up a new one, you're not going to be cited very much probably, unless you're used as ammunition within a controversy. But if everybody just accepts your argument and then just stops, then you're not going to be, why would you be cited? Whereas the papers that are cited typically are the ones that are provoking a lot of research interest at the time. And so sometimes this is obviously a sensible kind of thing, that this is what scientists do. They go and find areas that look particularly promising and they pile into those particular areas. But it tends to be the case that this means that the top cited literature will be positive, right? It is just seems to be the case, but I can't say I haven't pretended in this talk to kind of give a systematic overview of these things, partly because they don't exist yet. And what I've shown you is the difficulties in maybe ever being able to do it is that if every little research question has its own little literature, it's got its own little dynamics, and they all exist within kind of slightly larger kind of areas like Oxytocin, and these are sat within even bigger networks, such as biomedicine. So I think it becomes the case where you're not going to be able to understand biases without looking at very specific little areas and understanding what's actually happening in that area, whereas these large surveys are going to miss that. So please don't take what I've said as saying that this is gospel. It isn't. I think I wanted to kind of provoke people's interest and get them to reflect and be on the lookout for these things, rather than to kind of parrot the conclusions that I come to, which would be kind of the opposite of the point I was trying to get across in the talk, I think.
Wonderful. Okay, well, I've come to the end of my questions. I don't have any more. I think that's everything as well from the Q&A board. So just again, Rhodri, thank you so much for your time on this really fascinating talk, and I'll make sure to put this up on YouTube straight away. And also, if you send along your slides, that would be great as well. And we'll also signpost a few resources that you mentioned as well. But yes, thanks again. I think Ian has popped off, so thanks from him as well. I'll end the stream now, but you can stay on the call and we can just quickly debrief. So see you all next week, everyone.